Good morning, grade 9s. Hope you're all having a terrific Tuesday. Welcome to WorksheetCloud's grade 9 Natural Sciences lesson. If you have a question during the lesson, please send an email with your question to grade9@worksheetcloud.com.
Here we go.
So thanks to Sunset Sweatshop for coming along to our lesson. If you want to request a song at the start of a lesson, send it along with a question that you have to grade9@worksheetcloud.com. So come along and welcome to the place where learning is fun. I am Mrs. Ernston, your WorksheetCloud Natural Sciences grade 9 teacher. I am so glad that you could join me today for today's lesson. We'll be having a look at groups in the periodic table. We're going to look how the elements are arranged in the periodic table in such a way that those with similar properties are placed in the same group. We're going to see how rows in the periodic table are called periods and columns are called groups. That groups have got special names like alkali metals, alkali earth metals, transition metals, halogens, and noble gases. And I will mention it today, but it is more about tomorrow's lesson, and that is how atoms of a period have the same electron configuration. So as a recap from the lesson on Friday, or it could have been the lesson on Monday, what is the second element in the second period? So I'll give you a moment to try and work that out. So remember that these rows are known as groups and these rows are known as periods. So this is going to be, if we have a look at a period going across like this, this is going to be the first element, the second element, the third element, and so on. And this will be the 18th element in group 18. So what is the second element in the second period? So we're going to go, this is period 1, this is period 2. This is going to be the first element, this is going to be the second element. So yes, you guessed it correctly, it is beryllium that we represent using the symbol capital B, lowercase e. So which element is in group 18 and in the third period? So here's the periodic table. See if you can work it out. So it is group 18. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So we're going to find it in this group over here. And period, this is going to be period 1, period 2, period 3. So yes, you got it correctly. The element's name is argon, and the symbol for that is capital A, lowercase r. I will be dealing more with this in tomorrow's lesson, but it does link in with understanding the periodic table and the elements and how they react. So elements from the same group often have similar physical and chemical properties. So that means all the elements in this group are going to have very similar chemical properties. and the electron pattern is going to be very similar. So if we have a look at it, groups are the vertical columns. So this is going to be a group, that's a group, that's a group. And they are arranged according to the number of outer electrons in an atom. And remember, I'm going to be doing atomic structure tomorrow. So if this is a little bit confusing, just hang on to then. And then maybe you can come back and re-watch today's video and it will make more sense to you. But if you have a look here with hydrogen, in the outer shell, it only has one electron. If we move to lithium, in the outer shell over there, it only has one electron. If we have a look at sodium, in the outer shell, so there's the outer shell, it only has one electron. We move down to potassium, and we have a look at the outer shell, it only has one electron. For example, let's have a look at this group here, and let's see how many electrons are in the outer shell. 1, 2, 3, 4, 5, 6, 7. If we move down to chlorine, 1, 2, 3, 4, 5, 6, 7. Which means all the elements that we find in this group have got the same number of outer electrons. So, properties of elements in the same group. So let's start with group 1. They are known as the alkali metals. Can you write the name and chemical symbol of the lightest member of the group? Okay, but hang on again, before we go any further, it's alkali metals. What happens about hydrogen? Hydrogen is a gas, it's not a metal. So you can disregard hydrogen because hydrogen is really a non-metal, but we place it with the alkali metals in the periodic table because of the electron pattern that I've just been speaking about. So the metals of group 1 are known as alkali metals. Remember, you only need to learn the first 20 elements for grade 9, so you will only really need to focus on lithium, sodium, and potassium. So to answer our question, can you write the name and the symbol of the lightest member of the group? It will be lithium, and the symbol is going to be capital L, lowercase I. So if you do have your periodic table handy, I think it would be a good idea to write down the names of the different groups now. So you can pause the video now and you can complete your periodic table. I'll wait for you to get back, not a problem. So if we just recap the periodic table again, when we look at the groups, this is known as group 1, group 2, group 3, 4, 5, 6, all the way to group 18. In grade 9, we are not going to spend too much time looking at the transition metals. So it is important that you know that this group of elements here are known as the transition metals, but we're not going to spend too much time on them. Where we're going to focus on are these groups here. Now you will notice up at the top, that's known as group 1, and that there has got a Roman numeral number 2, and then here we have a Roman numeral number 3, but there's another Roman numeral there, number 3. So like I said, for grade 9, if we cannot focus too much on the atomic structure of transition metals, so what this Roman numeral number means, that is the number of electrons in the outer shell. So this group is going to have 1 electron in the outer shell. This is going to have 2. This is going to have 3, 4, 5, 6, 7, 8. So for example, with these inert elements or the noble gases, we know that it is group 18, and we refer to it as group 18, but we can also order it according to the number of electrons that we find in the outer shell, and that is going to be 8 electrons. So the next thing is when we have a look at the periods going across this way, that has to do with the number of shells that they have. And just a reminder of the naming of the groups, let's just go through that quickly. The first group is known as the alkali metals. Group 2 is known as the alkali earth metals. Group 18 is known as the inert elements or the noble gases. Group 17 is known as the halogens. We covered in our previous lesson that these elements here are known as the non-metals, but we mustn't forget hydrogen over at the top there is also a non-metal. This area here in purple is known as semi-metals or metalloids. So if you can't find a periodic table, you can go to our worksheets on WorksheetCloud, and I've put copies of the periodic table there for you to use. So I would like to thank Squiggle Mom for the use of their YouTube video. It is titled Lithium, Sodium, Potassium and How They React with Water, and it was published on the 10th of June 2013. Let's have a look and see what they can explain to us about Group 1 elements.
Group 1 metals are very reactive because they have low ionization energies. One of the ways that indicates its high reactivity is the way that we store the metal. Group 1 metals are typically stored under kerosene or mineral oil to prevent or limit the reaction of the oxygen in the air. Let's look at some of the physical properties for Group 1 metals. We'll start out with lithium. The lithium is coated at this point in time with a layer of both the oxide and the nitride, and we end up with a fairly dull gray appearance. Group 1 metals tend to be relatively soft, and we can easily cut the metal with a knife. What we can do is we can see the shiny metallic surface underneath. If we bring in a conductivity tester, we can see that the lithium is an excellent conductor of electricity. If we add a piece of lithium to the water, one of the things that we notice is the fact that the lithium floats. Group 1 metals are less dense than water. We also see that the lithium reacts very rapidly with the water. This is a single displacement reaction producing hydrogen gas and lithium hydroxide. The lithium hydroxide is very water soluble and dissolves in the water. The hydrogen gas escapes. If we trap some of the gas in a test tube, we can test if the gas is actually hydrogen by testing its flammability. We can test if lithium hydroxide has been produced by adding an acid-base indicator. If we add some phenolphthalein, phenolphthalein is colorful in acid and red-purple in base. We can tell that the solution is basic due to the formation of the lithium hydroxide. We'll go down the column on the periodic table in Group 1 and look at sodium. Like the lithium, the sodium is stored in a mineral oil to minimize the action of the oxygen in the air. If we remove a piece of sodium metal, we notice that it's also coated over with an oxide coating. Group 1 metals become softer as you go down the column. The sodium is much easier to cut than the lithium. As we cut the oxide layer, we can see the shiny metal underneath. It coats over very rapidly with a layer of oxide. The sodium is a metal and is an excellent conductor of electricity. If we take a piece of the sodium metal and add it to water, we notice a much more rapid reaction with the water. Like lithium, the sodium is less dense than water and flows. The metal moves across the surface, being pushed by the hydrogen gas that is produced. As you go down the column with group 1 metals, the melting point of the metal decreases. The reaction is very exothermic, which causes the sodium metal to melt. The metal contracts into a very compact spherical form. We can again test that hydrogen gas is being produced by this single displacement reaction by trapping the gas and testing its flammability. We can test for the fact that we produce sodium hydroxide by adding phenolphthalein. The phenolphthalein turns a purple-red color due to the presence of the hydroxide ions, indicating the formation of the sodium hydroxide. If we continue down the column to potassium, we see that the potassium metal is also stored under mineral oil to minimize its reaction with the oxygen in the air. If we remove a piece of potassium metal, we can see that the potassium is coated over with a gray coating of the oxide. As we continue down the column, group 1 metals get softer and softer. The potassium cuts very easily. As we cut through the metal, we expose the shiny metal surface underneath. The potassium is extremely soft. We can easily flatten out the potassium metal. It has a consistency of cream cheese. The potassium is a metal and is an excellent conductor of electricity. If we add a piece of potassium metal to water, we see that it reacts much more rapidly with the water than the sodium. As you go down the column, the ionization energy decreases and the metal reactivity increases. The reaction is very exothermic, and the hydrogen that's produced ignites. We can test for the formation of potassium hydroxide by adding phenolphthalein. The solution turns red-purple due to the formation of potassium hydroxide.
So thank you again for that clip. I know that there were some mentions about indicators and hydroxides. We will mention that when we get to acids and bases later on this year. So let's focus on the group 1 alkali metals. And I found this wonderful picture by at Light Bulb Science. So thank you to them that I could use this beautiful image to help explain alkali metals to you. So if we have a look at the periodic table here, we find the alkali metals in group 1. Just a reminder, we don't include hydrogen at the top. So if we think about the video that we have just watched about the reactivity, as you go down the group, the reactivity of the metal increases. And this is because the outer electron is further from the nucleus and there is more electron shielding. So as we go down this group, the elements become more reactive. Just to remind us, what are the alkali metals? It's lithium, sodium, and potassium. Those are the ones you need to learn for grade 9, but I'm sure your teacher will mention rubidium, cesium, and francium. If we try and remember the video, the lithium reacted and the water fizzed. When sodium reacted with the water, it melted into a ball and it skidded around the top of the water. When potassium reacted with the water, the metal actually sparked on fire and you saw a lilac flame. And then all of the group 1 metals made an alkali solution and they gave off a hydrogen gas when they react with water. So this little chemical experiment leads beautifully into elements and compounds and chemical equations. So just to recap, here is the chemical equation. The piece of lithium metal reacts with the water and produces hydrogen gas. So we're dealing with lithium. So there is the lithium. It's reacting with the water and it is producing hydrogen gas. And we know that that gas is hydrogen because of the pop sound that we heard. So what other product that forms is lithium hydroxide. So if we have a look at the equation here, can you find the chemical formula for lithium hydroxide in the chemical equation above? So well done, there it is. Li refers to lithium and hydroxide, the oxy refers to oxygen and the hydro refers to hydrogen. And that forms a compound where when oxygen and hydrogen combine, they can form a hydroxide in a compound. So an important thing at this stage when we start looking at chemical reactions is all I actually need you to be able to do for today is if I give you the chemical equation, are you able to write the word equation underneath it? So for example, lithium plus H2O is water. When they chemically react together, produces lithium hydroxide and hydrogen. So what are the reactants and the products in the above chemical reactions? So we always know that we have a chemical reaction when we see this arrow here. So the reactants are going to be the elements or compounds that react together. And obviously the products is produce. It's something that the chemical reaction makes. So lithium and water are the reactants in this chemical reaction, and lithium hydroxide and hydrogen are known as the products. So let's move down to the next element in group 1, and that is sodium. So sodium, remember, is more reactive than lithium. So here is going to be the chemical reaction with sodium and water. And can you see how similar sodium is to the reaction between lithium and water? So we have sodium plus water gives us sodium hydroxide and hydrogen, which is exactly the same as lithium. Lithium and water give us lithium hydroxide and hydrogen. So the similarities are that they both make the same type of products. They both make a hydroxide and they both make a hydrogen. The next element in group 1 is potassium. Now potassium, remember, is even more reactive than sodium. And there is our equation. And again, I would like you to see what similarities can you draw between the chemical reaction for potassium compared to sodium compared to lithium. So you will see in all cases we have the metal. In all cases they reacted with water. So the metal and the water are known as the reactants, and in the chemical reaction the metal recombined to form the metal plus a hydroxide, and then the hydrogen atoms combined. So can you see how similar potassium is to the reaction between sodium and water and lithium and water? So properties of elements in the same group. Look at the chemical equations of the reactions between the elements of group 1 and water. And just to recap, what do you notice? If you need to pause the video now while you copy these equations down and make a note of what you've noticed, that's not a problem. I will wait for you to get back. So if we summarize the group 1 alkali metals, they are the ones you need to focus on are lithium, sodium, and potassium. They are all active elements. They are soft metals with low melting points. They react with oxygen, and that's why they are stored under paraffin. They react easily with oxygen to form oxides. They react aggressively with water to release hydrogen. And the reactiveness increases from top to bottom in the group. So potassium is more reactive than lithium. And then if we have a look at the atomic structure, as we move down each period, we increase the number of shells. But if we have a look at the valence electron, if we have a look at the electron in the outer shell, they all only have one electron in their outer shell. If we have a look at group 2, those are known as the alkali earth metals, and the ones there you need to focus on are beryllium, magnesium, and calcium, and they have got a valency of 2. So if we have a look as we move down the periods, period 2, that's going to have 2 shells. Period 3 has got 1, 2, 3 shells in the atomic structure. In period 4, we have 1, 2, 3, 4 shells. So as we move down the group, with every period, we increase the number of shells. But what you will notice is in the outer shell, they only have 2 electrons. So beryllium's outer shell has got 2 electrons. Magnesium's outer shell has got 2 electrons. Calcium's outer shell has got 2 electrons. And that is why we find all of these atoms in the same group. Then if we have a look at group 17, this is fluorine, chlorine, bromine, iodine. And just to remember, you only need to focus on the fluorine and the chlorine. We call this group the halogens. They have 7 valence electrons. So what that means is they've got 1, 2, 3, 4, 5, 6, 7 in their outer shell. And let's have a look at chlorine. 1, 2, 3, 4, 5, 6, 7. So that means that when they react, they are able to receive an electron, and they will form an anion with a valence of -1. They are active nonmetals. At room temperature, fluorine and chlorine are gases. Bromine is a liquid, and iodine is a solid. They are all diatomic molecules. In other words, they are formed by the bonding of 2 atoms. They are all very poisonous, and the reactivity decreases from top to bottom in the group. So chlorine is more reactive than bromine. And lastly, if we have a look at group 18, these are known as the noble gases or the inert elements. They are inactive and do not form bonds with other elements. And the reason for this is they have 8 valence electrons. Therefore, they have a complete electron structure. They have no space or valency to receive or give electrons. Again, you just need to know helium, neon, and argon. So just to recap the elements of the periodic table, grab a pen and paper for you to copy this table down and press pause because I'm sure you'll need some time to complete this activity. So group 1 is called the alkali metals and they react readily with air and water. I would like you to go to the periodic table and write down what are the examples of the group 1 elements. In group 2, they're the alkali earth metals. They react with air, but not as readily with water. And I want you to go to the periodic table and list examples of group 2. Then we have group 17, also known as the halogens. They are non-metals and they are diatomic molecules. Please give me the examples there. And then group 18 are the noble gases or the inert elements. They are very unreactive non-metals. And you can go and give me some examples there. So if you pause the screen now and finish this activity. Well done. Here are the answers. So group 1, we have lithium, sodium, potassium. Group 2, we have beryllium, magnesium, calcium. Group 17, we have fluorine, chlorine, bromine, iodine. And then group 18, we have helium, neon, and argon. I will be discussing more of this in tomorrow's lesson, but just as a reminder, when we put the elements into groups, we look at the vertical columns and they show the number of outer electrons in each atom. You will notice here that I have taken away the transition metals. So elements from the same group often have similar physical and chemical properties. And that is because elements in a group have similar electron patterns in their atoms. So this is a sneak peek of what we're going to have a look at in tomorrow's lesson. So just as a recap, this is a slightly different periodic table, but I just want to remind you that please will you make sure you know the names of the different types of elements that we have on the periodic table. So here we have the alkali metals, here we have the alkali earth metals, this middle section here is known as the transition metals. These are metalloids or semi-metals. These here are the non-metals. This group here is halogens, inert elements or noble gases, and the elements at the bottom are known as the rare earth elements. So hope you have a happy Tuesday, and I want you to Tuesday. So choose to be happy, choose to be kind, choose to be grateful, choose to smile, choose to be helpful, choose to be patient, and choose to be the best you that you can be. Thanks for watching grade 9s. I had a wonderful lesson with you today. This lesson was brought to you by WorksheetCloud.